Hi everyone, sorry I'm out today, but I want to keep up with our calendar, so grab your notes packet and let's take a look at this Reflections Day 1. It says to reflect a graph means to draw its mirror image. So let me grab a pen here and jot down mirror image across our line of symmetry. So everything we do should look the same. It should just be in reverse image. That's our mirror image. So when we look at these two shapes we have down here, we have an arrow pointing right and we have a star. If we're asked to draw a reflection over the given line of symmetry, and that's the line right here to the right of it, what would this look like? So if we were to take this arrow and draw a mirror image of it, wouldn't it be facing the original arrow? Kind of like if it were wet paint on a piece of paper and we folded it over. This is what our image would look like if it matched over to the other side and left an imprint. Likewise, the star. Right now it has one point facing up, kind of away from the line. It has 2 points coming down towards the line. So our mirror image would be a star that has these two, oh goodness, see if we could draw this, these 2 points by the bottom, like, oh Lord, I hope your star is better than mine, but it has 1 point up away and it has 2 down below. And that's what we're doing with reflecting. We're reflecting top to bottom over our horizontal line, and we reflected right to left over our vertical line. So let's talk about this for a minute, and we're going to put it to use with some graphs. So down below here, on the page, it said there are 2 ways that we could reflect on our coordinate plane. So on our coordinate plane, we could reflect across the x-axis. In order to reflect across our x-axis, remember our x-axis is our horizontal axis, that means we need to reflect, if this is our x-axis, top to bottom, which means we are going to be changing the y-coordinate. And the y-coordinate will change by way of taking their opposite. So if it's a positive up in the top, it's going to reflect down to the bottom as a negative. So say we had an absolute value graph up here, opening upward. If I reflected it across my x-axis, I would end up with an absolute value graph down below but opening downward. Now, how can we identify these transformations in our equations? Well, we talked about function notation before, and we used it yesterday. In our f of x notation, we can tell that it's an output change if our negative sign is outside the f of x. It's not inside that parenthesis or that grouping symbol, whatever it might be in that equation. So a couple examples would be, we'd have a negative out in front of the x squared, no parentheses involved. We'd have a negative in front of our absolute value. These are all output changes. So that tells us we are going to reflect from the top to the bottom over that x-axis. So negative is not in the grouping symbol. So you'll have to look at your function and decide what that grouping symbol is. All right, our other option would be we can reflect over the y-axis. Our y-axis is our vertical axis. And if we're going to reflect over the y-axis, picture if we had like a triangle. Okay. If I needed to reflect over the y-axis, it would be the same triangle, or at least as close as I could draw it to the same triangle, and we would be reflecting right to left. That looks like a little smiley face. So every point on the left side would have its matching point on the right side. So think about what would be changing if I went left to right. This is what we refer to as an input change. Remember, left to right, input is our x value would be changing. And we would change it the same as we did up above by taking the opposite of all of our x coordinates. So you'll notice the difference. It's very slight, but now look where that negative is at. It's inside the grouping symbol. Every one of these examples has our negative sign inside the grouping symbol. So jot that down. Negative. That's what's telling us its reflection when we see a negative sign is inside the grouping symbol. So we're going to have to be very careful reading these equations and paying close attention to where things are placed within that equation. All right, so let's take a look at an example. Here's what we have: a parabola given to us, we have a graph given to us, we have the coordinates for that graph given to us, and take a minute and look at the f of x, the equation. I'm going to grab a different color here. When I look at my f of x equals x squared, this is our parent. Okay, that's the parent function, which is this exact graph that you see on your coordinate plane. Our new equation that we're going to look at has my negative right there. It's negative f of x, or we have the negative not inside a grouping symbol like parentheses. It's out in front of the x squared. Now remember also, f of x is a fancy way for saying y. So doesn't this really say negative y? That's exactly what we're going to do. We are going to take the opposite of all the y's, of all y coordinates. And how we refer to this in terms of what type of transformation it is, it's referred to as reflect over, and then we have to decide which axes. So if I'm taking the opposite of all of my y coordinates, all these y coordinates that are positive here in our list of points are all going to become opposites. They're all going to take on a negative. So that means all of these positive y points up top are going to become negative y points in the bottom. We're going to reflect over the x-axis. All right, perfect. So as we go through, take a point, change the signs. Well, 0, 0 doesn't carry negative signs, so it'll stay 0, 0. Instead of negative 2, 4, the y coordinate, all of the y coordinates, we want the opposite of the y's. Okay? Take the opposite of all of the y's. So even our positive 2, positive 4 becomes a negative 4. Same thing with the 3 and the negative 3. Those 9's now become negative 9's. So you could either change all the coordinates in the point form over here on the right, or you could look at your graph and say every point, I'm going to move it down towards the bottom. So here's my 0, 0. My point 2, 4 is now going to be 2, negative 4. 3 over 9 up will be 3 over 9 down. Everything is switching direction. Instead of going up 4, we're at negative 2, down 4, and negative 3, down 9. And it still makes that same parabola when we go through and connect all of our points. It's that mirror image from top to bottom that causes us to have the exact same parabola reflected over the x-axis. All right, I would like you to please go ahead and hit pause. When you look at the next page, you can see a problem up on the top, number 2. Give that a try on your own. Thanks. And then hit play again, and you could check when you're done. All right, welcome back. Take a minute, check number 2. Check your graph, make sure the points are in the right place, make sure it's opening downward. You have a list of coordinates over on the right that you can look at. And in this big box here is our actual transformation. Reflect over the x-axis. Okay, on to number 3. We have our graph. It's a triangle. It's not a function, but it is just an image, a triangle. And we want to apply the change of having the negative inside the grouping symbol. Inside the grouping symbol tells me this is an input change, which means it's all about the x's that will be changing. That's our input. So we're going to take this graph, and in order to change the x's, it's going to need to reflect right to left. Negative x's to positive, positive x's to negative. So our graph is entirely on this left-hand side, the negative side. We are going to take the opposite of every x coordinate. As we go through and take the opposite, we're going to look and say, at this point, it's over 2 and up 4. Now it's going to go over 2 and up 4 on the other side of the axes. Now instead of a -2 for the x, it has a +2 for the x. And we're going to go to every point and apply the same change. This point over here is way out at -5. Now it's going to be out at +5. 1, 2, 3, 4, 5. Every coordinate, we're going to take the opposite. We're not going to move up and down at all. We're going to move 8 instead of to the left. We're going to go 8 over to the right. And our graph, when we connect the dots, should be that mirror image over now the y-axis. So our transformation is called reflect over the y-axis. That's the actual transformation that's happening. How we do that transformation is we take the opposite of every x coordinate. So if you like your table of values, your list of points, every x coordinate will change to the opposite value. So instead of -2, 4, it's +2, 4, and a +8, 8. We took the opposite of the x. All right, back to being your turn. Move down to number 4. Give number 4 and 5 a try, and then come on back when you're done and check. Be careful, number 5, 2 transformations happening. It does not matter which order you do first, but make sure you do apply both changes. All right, welcome back again. Let's take a quick look at these. Up on the top in number 4 here, you have the negative on the inside. That's telling you an input change, and you are going to take the opposite of your x's. So make sure you said that every x coordinate was changing and being the opposite, which means you are going to reflect right to left over your y-axis. To change the x coordinate, you have to go over the y-axis. Same thing on the bottom. Down on the bottom, you actually had 2 changes being made. You had one negative outside, if you read it carefully, and one negative inside. So outside is affecting the output, the y. We'll be taking the opposite of the y. The inside negative is saying take the opposite of your x, your input change. So we will be going over to either our coordinates or our graph, and we will be taking the opposite of each one. So our -2, -1 will become positive and positive. The coordinates for each one of those points will become the opposite of what you originally see, and that's causing you to help reflect your image over the axes. And I do apologize, I forgot to connect that point. Maybe that's why it looks so different to me. So the transformation's happening. 2 different transformations were happening, one for each of those negatives. We reflected over the x-axis because of that outside negative, changing the y-coordinates. We reflected over the y-axis for the inside negative that was changing the x-coordinates. So I hope all went well with this video. I know it went a little long. If you are done with this note sheet, go ahead, check it in. And I'm sorry about that, it disappeared, it's back. Go ahead, check in your note sheet with the substitute, and he or she will give you a homework sheet for you to work on. So do the best you can, and we'll come back and revisit this again on Monday. Thank you. Have a great weekend.